हेलो स्टूडेंट्स, एक क्वेश्चन देखते हैं। देखिए इस क्वेश्चन में क्या है, टू वेरी लॉन्ग स्ट्रेट पैरेलल वायर्स carrying a steady current I and minus I. So let us take the current I am right, the wires I take here very long. So let us take this wire is very long and current the carrying I. Another wire is also there which are parallel to each other. It is given in the question and it is carrying current minus I. It means in opposite direction. Okay, respectively. The distance between wire is D. So let us see. First I am trying to make the figure. The distance between wire is D here. Okay, at a certain instant of time, the point charge Q is at a point equidistant from the two wires. Okay, so one point charge is there Q, and the distance from here to here is D by 2, and here also the distance is D by 2, right? And here the charge is Q. Okay, at this point the charge is Q. Okay, so now okay, this is given in the question, right? At a certain, okay, now okay, in the plane of the wires. Okay, so it is in the plane of the wires. Okay, its instantaneous velocity v is perpendicular to the plane. So it is having the velocity v that is perpendicular to the plane. So the velocity vector is, let us take, it is directed into the plane of this plane of the blackboard. Okay, the magnitude of force due to the magnetic field acting on the charge at this instant. So you have to find the magnitude of magnetic force. Okay, now see, right, for this wire the magnetic field will be perpendicular to the plane. For this wire also magnetic field will be perpendicular to the plane. So one thing is sure, right? So let us call this point is O. So I can see here the magnetic field at O, right? Magnetic field at O will be perpendicular to the plane containing wires, because for both the wires, because for this wire also plane, right, field will be perpendicular to the plane, and for this wire also field will be perpendicular to the plane. So the summation of both the fields will be perpendicular to the plane only. Okay, now it is saying the charge is also having, I mean it is saying, it is given in the question, Q is having velocity perpendicular to the plane, So from these two statements I can easily see the angle between V magnetic field vector and the velocity vector will either be 0 or 180 degree. So I can say here where theta is the angle between, if theta is the angle between B vector and B vector, then theta will be either 0 or 180 degree. Okay, this I conclude from these two statements. Now it is saying what will the force on this charge. As you all know, the force will be Q V vector cross product B vector, and that is nothing but Q V B sine of theta, right? Now you are seeing the theta is 0 or it may be 180, but for both the cases the sine theta will be 0. So whatever the angle is, doesn't matter, the sine theta has to be 0. So this angle will be 0, and so the overall product will be 0. So the force will be 0. So see which option is coming, option D. Okay students, I hope you understood this question.